Greetings of the day to all. I'll be starting the session right now. Hello and greetings to all. The authors and invited guests, welcome to Technical Session 3E. Myself, Prashi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of this conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th of April 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On the 9th minute, I will be raising a gentle reminder. There is another request to all our participants that you stay connected to us till the closing remarks. If you have any queries or any updates, you can write it to me in the chat box given down below. Just before we start our session, I would like to introduce you all to our session chairs for this session. Professor Imavin Rahyati is an associate professor at Bina Nusratan University, BINUS, specializing in media studies and political communication. With over 14 years of experience in academia and industry, his research interests include digital political marketing, new media and society, digital marketing communication, and pro-social public relations. We welcome you to the session, sir. Would you like to say a few words before we start our session today?
Thank you. I'll be listening and monitoring and to listen to all the presenter and the research. Thank you. I still mute, Prachi.
Yes.
Prachi, you are not audible.
Yes. On that note, I would like to call upon I'd like to introduce our next session chair, Dr. R.K. Taylor Dr. R.K. Taylor is the director at Chhatrapati Sahu Institute of Business Education and Research, CSIBR, Maharashtra, India, with over 16 years of teaching and research experience. A renowned expert in robotic process automation and accounting. He has authored more than 50 books in the field of commerce, management, and technology. We welcome you to the session, sir.
Thank you, Prachi, and I welcome all the paper presenters and my colleague Erwan for chairing the session, and will give all the best to all the paper presenters. Thank you so much.
Thank you so much, sir. Now, after the introduction, I would like to call upon our first presenter for this session. Our first presenter for this session is Deepak Sharma, presenting a paper on the title, A Bibliometric Analysis of Research Trends in Finance, Mapping Intellectual Structure and Emerging Themes. I request you, if you are available with us, kindly take over with your presentation, please. So, Deepak Sharma. Okay.
We can go with next.
We don't have, we don't have him present over here. So, according to the availability of our participants available over here, I would like to call upon our next presenter. Sir Vazalev, presenting a paper on the title, Fast Channel Bit Rate Estimation Through a Novel Approach, Approximity EVT Estimate. I request you to kindly take over with your presentation, please. Sir Vazalev.
Hello, yes, I'm here.
Yes.
Can you hear me?
Yes, sir, we can hear you.
Okay, let me try to share my screen. Can you see my screen?
Yes, sir, we can see your screen.
Yeah.
Thank you. Hello everybody. My name is Vladislav Vasilyev, and I'll present our paper on fast channel bitrate estimation through a novel approximate EVT estimate. The problem formulation is the following. A channel estimation is still an active area of research for a number of reasons. First of all, the SNR limits might be incongruent to the types of traffic that the users are demanding. On the other side, the scheduler cannot wait indefinitely to make a decision on the channel mapping. And for that reason, there are always a limited number of measurements, and they are typically very noisy. And this makes the channel estimation very difficult. For that reason, extreme value theory is very commonly applied for channel estimation. Typically, researchers apply the state-of-the-art of AVT to the problem at hand, whatever that engineering state is. Our approach is a bit different. We try to adapt the theorem itself to the problem at hand. Because we're seeking faster ways to estimate the channel. One particular approach that is not well researched in the literature is the use of the information function, as we will see. And the advantage of this particular approach is that the estimate is an explanatory model. This means that we always can explain why the estimate made the decision or produced the values compared to, for example, a neural network. One drawback of this method is that it's a one-dimensional estimate, meaning that if we want to do multi-dimensional estimates, we have to apply some sort of dimensionality reduction first. And to begin with, this is the statement of the extreme value theorem in its raw form, and we resolve to use this particular formula because it doesn't require it uses fewer parameters to define the problem. And to start off, we first move all the parameters A and B to the right side. And then, as we said, we're going to take the information function, but not once, but twice to get this particular formula 3, which is an equivalent form. The difference is that all the unknown parameters on the right side, and on the left side, we have this quantity which can be estimated from the data. And to simplify the formula, we just substitute some of these constants to get this more compact form. At this point, we notice this particular property of the logarithm. Specifically, these normalizing constants can be moved outside of the logarithm at will. In this way, we are able to push this scaling A outside of the logarithm. Basically, just multiply the numerator and denominator with this constant here, and we split the logarithm. And this allows us to scale the input variable x. And as we see, we'll be using this a number of times, and it will allow us to solve the problem really fast. So first of all, we apply this formula to what we had before, and we get these particular results. We have a number of constants that we can substitute to get a more compact form, which is basically this equation 9. The next thing we can do is, because we're able to scale x, we are able to scale it in such a way that we can apply actually the Taylor expansion. And to this end, we basically define a different variable z, which is basically a scaling of x in such a way that the new variable z is actually in the interval minus epsilon plus epsilon, which will allow the Taylor expansion. We basically substitute z in this equation 10 to get this form. And once again, we would like to get as fewer constants as possible. So we're going to substitute, and we're going to expand. Particularly, we're going to move some of the constants outside of the logarithm. And we're going to move also this scalar x outside. And basically, we end up with this equation 15, where we can see that we have very few constants. Particularly, the input variable z is actually in the interval minus epsilon plus epsilon, so we can apply the Taylor expansion. On the left side, we have this quantity, which is twice the information function of the CDF, which is computed empirically from the data. And if we apply the expansion, we basically end up with this equation 16. And we can see that it's a quadratic equations where we can map all the model parameters theta 0, 1, and 2 to actually parameters in the expansion. One thing that is particularly interesting, and it's actually very important, is that the unknown parameter gamma, which is a very important parameter where we do extreme value theory, actually because C4 is taken to the power 2, this means that the parameter theta 2 directly tells us the sign of the gamma parameter, which means that if we plot the data against this quantity, we can visually inspect, and the concavity of this quadratic function directly tells us the sign of the gamma parameter, and we will see that in the simulated data in a bit. But before that, we can first derive the actual mapping of the constants. First of all, this parameter C4 is basically the inverse of the theta 1 parameter of the regression. And once we have C4, we can directly compute gamma because it also maps to the theta 2 parameter. And this gives us this result. And finally, because we know gamma and C4, we can also estimate this parameter H2. And this gives us those values here. One particular problem with this regression is that because Z and the information function, twice the information function of the CDF, are on very different scales, the regression often runs into issues with scaling and falls in local optima. And one particular way that we have proposed to solve this issue is to use Newton's interpolation, actually the second order Newton interpolation, simply because we already showed by the Taylor expansion that after we scale, we have a quadratic function. This means that if we pick 3 random points in the data, or if we will basically be able to compute these unknown quantities A1, A2, and 3, and we will produce this quadratic approximation really fast compared to regression, which will have to be initialized, and then we'll have to do gradient descent, for example, and we might run into local optima. So basically, the estimate goes as follows. Basically, we start with the unknown parameter, the unknown input variable X, which is the channel bitrate, which is gathered by the 5G user equipment. Then what we need to do is basically sort the data in ascending order, which takes n times logarithm of n steps. And in the sorted data, the CDF is computed very easily. It's basically the index of the data in the sorted order divided by the total number of data points, which is a linear scan of the data. And finally, applying Newton's interpolation is basically a constant number of steps because we take 3 random points, which we know that fits a quadratic function, and we directly use the formulas to compute the unknown parameters. So in essence, if we're trying to guarantee the bitrate, the computational complexity is basically that of a scan of a sorting function, which is n times logarithm of n. And this is considered relatively cheap in the world of computational complexity. So let's look at some data examples. Here, we start by simulating data input variable X from Pareto distribution. And here on X is the data we simulate, and here's the CDF. Typically, the extreme value theory is applied only on the right tail of the data. So, for example, between the 80th percentile and the, let's say, 98th percentile. And within that range, we can plot here in the middle the mapping between the Z value and twice the formation function of the CDF. As you can see, it follows a quadratic function, and it's curving upwards, which directly tells us that the gamma parameter is positive. So we can visually inspect that this estimate was correct. And then here on the right side, we show the actual mapping after we compute all the unknown constants of the model. And to see just a different example, if we sample, yes?
It's just a gentle reminder that we have exceeded the 9-minute mark. So I just request you to kindly conclude as soon as possible, please.
Okay, sure. Yeah, so I was just going to say that here, because the gamma parameter is negative, we can directly see it from this plot. And basically, as I just got some acknowledgement and reference, this paper was sponsored by a DCU project, and I have special thanks to Cyril Murphy, who greatly helped me with the investigation and encouragement. Yeah, that's basically it. If you have any questions, I'll be happy to answer them.
Our session shares. So do we have any questions?
Yeah, I have one question on that. It was really nice presentation, and the topic was really very good. Can you please share me one thing that what is your base when you are selecting this topic and when you're concluded on this particular research? What was your base?
Sorry, what do you mean base? You mean like motivation?
Yeah, what was your base to start this study?
Yeah, so I was trying to do estimates of extreme value. I was trying to apply extreme value theory to a different KPI. Actually, I was modeling. I better not say exactly what KPI I was modeling, but what I had to do is I had to apply thousands of times, uh, really fast, and the estimates were such that I wouldn't be able to manually inspect them. This means typically when we do extreme value theory, people apply to, let's say, water level, rainfall, things like extreme events, and they typically can actually look at the data, and they have, like, let's say 100 measurements of, let's say, flooding events or rainfall, and they have a lot of time to evaluate all these parameters and what the CDF looks like. But with telecom data, it's not like that. Typically, if you want to apply extreme value theory, you will not be able to inspect every single result. So there will be thousands and thousands of estimates and thousands of decisions, and you won't be able to look at them. And channel estimation is exactly like this. Nobody will be able to validate manually. You can only compute the formula and then hope that it will perform well.
Yeah. Okay, fine. Thank you so much.
Thank
Done
you.
from my side, Prachi. Yeah, thank you. Yeah. Anybody, Raman, if you have.
Yes, I do have. Interested. Thank you for the presentation. Is really detailed, and I like the figure also and the formula. Can you go back to the second slide when you talk about when you mentioned an AI algorithm? Is it the second one or the first one? I forgot. I think the second one. There you go. The number 4. So
Yes.
a more elaborate AI algorithm. Is this the one? Is this your aim, or is this? Can you elaborate, or can you explain more about this in point 4? What do you mean
Yes.
by?
Yes.
Go ahead.
For example, if we use, let's say, a neural network and we feed it a lot of data, and we try to, and the goal would be to, let's say, try to predict extreme events. The neural network will come up with some estimate. It could be really accurate, but because the neural network itself is a black box, it's difficult to understand why is it producing the values that it's coming out. And it's a typical issue with all modern neural network algorithms. For example, they cannot directly explain why we're getting this data. Whereas if we perform, let's say, extreme value theory, there's a direct formula. We just apply the formula. We know exactly what the limitations of the formula are. For example, here we use Taylor expansion. So we know that it's accurate up to the second order of the expansion. We know exactly where this formula comes from. and we know that, for example, it will struggle to map linear functions. So, for example, because it's non-linear and the uniform distribution is linear, so it will be accurate in some areas, but it will not be as accurate in others. And we can explain that to let's say to the customer or to an engineer, and we know why it will perform exactly like that. Yeah, that's the point before of that point 4.
Right, so it's an advantage, yeah.
Sorry?
Right. So it's an advantage, I said.
Yes, it could be considered as an advantage. Yes.
Right. And it's very sellable now with the Gen AI all over the place now, right?
Yeah,
Okay, then.
yes.
Thank you for the answer and thank you for the presentation. I'll get back to you.
Thank you.
Thank you so much, sir. Thank you for your presentation. Thank you, our session chairs, for the question. Now I would like to call upon our next presenter for the session. Our next presenter is Lincoln Liu, presenting a paper on the title, Interactive Visual Analytics for Fidelity, Assessment of Synthetic Tabular Data. I request you to kindly take over with your presentation, please. Sir Liu.
Hello. Thank you for introducing. I'm going to introduce my share my screen.
Okay.
Okay.
Yes, sir.
I think yeah. Okay. So can you see my screen? No?
Yes, sir. We can see your screen, sir.
Okay. Oh, it's not this one, right?
So you can put it on slideshow. It is there in the top. Cross this window. You can put it on slideshow.
It's okay for you?
Our session chairs, sir, is
Yeah,
it
it's okay. It's
visible?
okay. It's okay. You can
Okay.
continue.
Oh, sorry.
Yeah, it's okay.
Sorry about that. I don't. No, okay. Thank you very much for introducing me to present our paper. This paper is funded by the EPSRC in the UK, and it's about making visualization scalable for explainable AI. Our team members from different schools at the University of Leeds. For example, computer science, transport study, design, math. And today's topic is about objective 3, applying the visualization techniques to real-world scenarios. The topic is interactive visual analytics for fidelity assessment for synthetic tabular data. Our co-authors from the University of Leeds and our industrial partner for extra technologies. The synthetic data is widely used due to the privacy constraints. For example, in the specific domains, finance and healthcare, some domains like this, it contains multiple personal informations, and generally we generate the synthetic data to make it be usable as well as the original data. But what is the challenge? The challenge is to evaluate the usability of a synthetic data. The existing method, either focusing on single quality scores like this one, it generates the synthetic data, and then they evaluate the synthetic data using the specific metrics to tell the users, if what scores your synthetic data received. And the second existing methods are about static visualization technique. For example, the heat map to visualize the correlation between two variables, or the bar chart or histogram to visualize the distribution of data, something like that. But there is no interactive visualization to help users explore their synthetic data step by step to tell them what the reason that their synthetic data failed. So our contribution is to design an interactive visual system to evaluate the fidelity of synthetic data with unified validation framework, embedding-based anomaly detection, and we also merged AI assistant to make users be interpretable. And this system contains three sessions. The first is a database here, and another session is about validation part. It contains the various statistical tests, including the multivariate, univariate, and bivariate. And another important part is the embedding pipeline. We use the dimensionality reduction method to reduce the dimensions of multiple dimension data into a 2D data. The first step of the system is data upload and validation. We support the CSV and Excel file, and it can ensure the comparability before analysis. This is an overview of the data upload. We can upload the real data set, synthetic data set, and then we can choose the parameters, configure the parameters for dimensionality reduction. Our system provides users with two methods for dimensionality reduction, UMAP and TSNE, to project high dimensional data to 2D. And eventually our system provides the scatter plot here, like this one. The scatter plot has real and synthetic data, and blue for real and orange for synthetic data. These scatter plots can help users review clusters, outliers, and structure of their data. It says our system, based on the embedding space, based on the scatter plot, we provide anomaly detection. First, we gridify the display into the different cells, and then we compare the proportion in each cell between real and the synthetic data to the proportion of the whole data set between real and synthetic data. We call it a false discovery rate correction. So eventually the output is like this. If the real data set in a cell like this one, if the real data set is overrepresented, that this means the proportion of the real data set in this cell is much higher than the proportion of the whole data set between real and synthetic data. We call it real overrepresented, highlighted with blue, and in contrast, if the synthetic data is overrepresented, we highlight it using orange one. And then our system also provide statistical analysis, including the different metrics for univariate test, bivariate test, and multivariate test, and so on. And our system also provide the visualization results, like we're using the bar chart or histogram to visualize the distribution of a specific attribute in the data set. For example, this example shows the sex distribution in data set. We also provide other visualizations such as the variant plots for plotting the correlation between two variables. Our system also provide the AI assistant. We use LM for the interpretation, and in the system based on our set prompts to generate the report. That report can highlight some important information, such as the risk and the key difference between synthetic data and the real data. Our system also provides the job management and monitoring to make our system be reproducible. Our system can store the key information, for example, the generated scatter plot, some other information like how you implemented your workflow. It makes it supports the scalable and reliable validation workflows. We conducted an experiment using the insurance data set. The result showed that it can detect anomalies in charges and children variables. Besides, our AI system can provide key findings of the synthetic data. For example, in these key findings, like it shows extra blank column in synthetic data. It means that in our synthetic data, we have extra column that original data doesn't have. But this column is there. There is no title in this column. So our system can provide a multi-level validation. Is essential for evaluating the synthetic data. Our system combines the statistics plus visualization plus AI. It improves the transparency and the usability of synthetic data. Our system can also support the decision-making basis. And in the future, as the current dashboard doesn't contain enough information to help users explore their synthetic data step by step, to tell them some specific reason why their synthetic data failed. So in the future, we can provide more complex, more useful dashboard in our system. And besides, the current version can only focus on the tabular data. In the future, we can expand it to make it can evaluate the time series data and even the images data. Eventually, we can conduct the larger benchmark studies in the future. And to summary, our system provides a practical validation framework. It ensures trust in synthetic data. It also supports a safer data sharing and AI development. Okay, thank you very much. I'm happy to take any questions. Thank you.
Our session chairs. Sir, we do have any questions?
Yeah, I have just a question, Liu. You did very good study, and it is really very good for the field study. Okay. The result which you have taken in that's particularly synthetic tabular data and the other tool which you have applied here. Can you explain what was the range which you have taken to explain to added all these things in your analytical part?
Sorry, reason for what?
What was the range which you have selected?
Range.
Yeah,
Sorry, can you repeat it? It's,
you have taken some tabular data, right? You're talking about to analysis of this data. So what
okay.
what was your range, lower and higher?
Okay. You mean I it depends on the data set. As far as I know, our system currently can visualize or analyze the data with the range as much as possible.
Okay, you can say
The current we have one data set. It has around 50 dimensions.
okay.
So 50 attributes. I think is the most one. Yeah, around
Okay.
50 dimensions. Yeah.
Mhm. Okay, fine. Thank you. Yeah,
Thank
Arman,
you.
if you have any question.
Yes, I'm interested in, hello, Liu. I'm interested
Hello.
in your anomaly detection, right? So while after your system detect anomaly,
Yeah.
what benefit does it do to the whole result or to the whole recommendation of your system?
Okay. It's because this system is collaborate with our industrial partner. What they want is after detected the anomalies in the here in our system, they will go to the detail of the data set to see what happened in the specific data items in their data set, and then to check their specific values or dimensions or attributes to see what the specific data difference between the synthetic data and the real data. So by doing this, they can modify their generative models to regenerate the synthetic data.
Okay, noted. Thank you.
Thank you.
Thank you so much, sir. Thank you for your presentation.
Okay, thank
Now
you.
would-
Thank you very much.
Thank you. I would like to call upon our next presenter. Our next presenter is Ashwin Babu Mampillai, presenting a paper on the title EV to EV, a fuzzy controlled dual active bridge for intelligent charging. I request you to kindly take over with your presentation, please. Sir Ashwin?
Yes, ma'am.
Yes, sir. Kindly take over.
Ma'am, is the screen visible right now?
So yes, sir, the screen is visible.
So our project is EV to EV, a fuzzy controlled dual active bridge for intelligent charging. So our group members, we did the project as a group of 4. So Amal Suresh, Ashwin Babu,
Adon Hill and Akshit Charan. I am Akshit Charan. Babu could not attend the meeting due to some unforeseen circumstances. So the rise of EVs has created an urgent need for flexible and efficient use of the charging infrastructure. So our project can be used as a backup or as an emergency service, which can be used to charge one EV using another EV when there is no grid infrastructure available. So our main problem definition is the persistent fear of battery depletion during long distance travel creates a significant psychological barrier to electric vehicle adoption. So our project basically helps the people to get rid of the uh, fear of battery discharging. And the vast geographical regions lack the grid connectivity, which is required to support the standard electric vehicle charging stations. So, and natural disasters or grid failures rendered the stationary charging networks inoperable for extended periods. So, a project can be used in disaster management purposes. Our main objective of the project was to design a decentralized vehicle-to-vehicle energy transfer system that mitigates the range anxiety by enabling immediate charge sharing from nearby donor vehicles. And our main objective was to utilize the fuzzy controller to ensure a robust and stable power transfer during emergency scenarios where the standard grid references are unavailable. And we demonstrated a highly adaptive charging network that enables flexible on-demand energy exchange between compatible electric vehicles without complex communication networks. So our project hardware mainly consists of a dual active bridge which was connected to both the batteries, and our relay module was used to decide which side the charge should be flowing. That is to connect the dual active bridge or the dual active bridge to the battery or the battery to the voltage sensor. The voltage sensor was used to calculate the SOC of the battery, which was fed into the microcontroller, which was used to run the fuzzy logic as, and the voltages were taken into the fuzzy logic as their inputs. So our simulation parameters were using the power GUI block of sample time of 1 microseconds. Then we took a battery of, we took two batteries of similar specifications, which was 12 volt and 9 ampere hour, which was a standard available as lithium battery. Then our working frequency for the dual active bridge was 20 kilohertz, which was used as a fixed pulse. So our fuzzy control use was Mamdani type fuzzy interference system, which had two inputs, which were the battery voltages and one fussified output. So the power flow, which was available inside the dual active bridge. The first B1 to B2 charging, these two states interchanged, which was useful for running which was useful for transferring the power through this transformer. This transformer was mainly used for galvanic isolation between the two vehicles, which acted as a protective system. Then for B2 to B1 charging also, the opposite MOSFETs were fired, which allowed the transfer of power from one vehicle to another. This were the basic simulation we done. This was done using MATLAB Simulink. So these are the fuzzy controller. So in the left side, we use some switches which were used to decide which side the power should flow from battery 1 to battery 2 or battery 2 to battery 1. Then the right side switches decided if the charge was to be transferred or not, because when both the SOC were equalized, the charge should be stopped. These were the results we got for the simulation. Here we can see that the battery 2 had an SOC increasing and battery 1 decreasing. So the output voltage of battery 1 was a bit higher than the battery 2. So till both the voltages equalized, the fuzzy control dual active bridge transferred the charge from battery 1 to battery 2. And the vice versa happened in the next case, which was transferring the charge from battery 2 to battery 1. So these were the algorithms we used. The main part of the algorithm was starts from step 15 to 17. If the fuzzy level was higher than 0.5, we set the power transfer direction from battery A to battery. And if the first level is 0.5, then the set is set to balance. Uh, H will be 5 the of the and the if the transfer so on was working as a inverter A side H bridge was working as a rectifier. The short circuiting of the MOSFET due to residual charges in the gate. Then we continuously monitored the voltages and repeated the process. So in the repeating the process, we had 10 seconds of check time, which was followed by 5 minutes of charge transfer time. These were alternated till the battery voltages equalized. The fuzzy logic controller output is less than 0.5. The H bridge is connected to the battery B as activated, and the power flows from battery B to battery A. If the fuzzy controller output was approximately 0.5, the system is considered as balanced, and none of the H bridges were actually switched. If the fuzzy controller output is greater than 0.5, the H bridge connected to battery A is activated, and the power flows from battery A to battery B. If the active H bridge operates as an inverter with a fixed pulse of 50% duty cycle, while the opposite H bridge acts as a rectifier. For the H bridge to act as a rectifier, we did not need to provide any additional gate signals as they had inbuilt diodes inside the MOSFET we used. The controller continuously monitors the battery voltages and updates the fuzzy output to determine the appropriate direction of energy transfer. This was our final hardware which we built. We can see the two H bridges and an isolation transformer in it. As a conclusion, we proved that fuzzy logic eliminates the need for complex mathematical modeling and allowing the system to adapt instantly to different battery states and load demands with superior stability. Then we successfully integrated an ESP32 based IoT framework that allow users to monitor critical charging parameters such as SOC, voltage, and direction of power flow. So we had submitted the conference paper, and we had did a national level project exhibition at St. Gibbs College of Engineering, Kottayam, and we had an approved patent in the intellectual property of India. These are thank you.
Thank you for your presentation, sir. Our session chair, sir, do we have any questions for sir?
It was really good presentation and a good topic, Ashwin. I congratulate you. I do not have any question on that. Thank you.
Thank you,
Thank you.
sir.
Thank you.
Sir Riyadi, sir, do we have any
Yeah,
questions from your end?
I got one question. Does the specification of your battery 1 and battery 2, the
Yes, sir.
specification of battery 1 and battery 2 is the same, right?
Yes, sir. For the prototype, we used it as the same.
Okay. Does that significantly affect the power flow?
Yes, sir. When it comes to real life, the power flow will be significantly affected because the battery needs different voltages for different batteries, for different electric vehicles.
Okay.
So in our prototype, we use the same battery, but when it comes to real life, we'll have to use some adaptive methods.
Okay, so if you change like the ampere into 12 or higher or lower, it's gonna change the whole result, right?
So basically, the almost the same.
Can you hear me okay? Am I audible?
Yes, sir, you're audible.
Yeah, I think you are.
Oh, it's okay.
Power.
Sure. Maybe Aswin network is not that good.
Exactly.
It's okay. I'm satisfied. Thank you. It's good study and best of luck with your research and project. Okay. Thank you.
Thank you so much for your feedback, sir. And thank you, Mr. Ashwin, for presenting. Now I'd like to take upon our next presenter for the session. Our next presenter is Queen Lee presenting a paper on the title on estimating infinite value of a circumference ratio. I request you to kindly take over with your presentation, please. So Lee.
Hello.
Hello, sir. I request you to kindly take over with the presentation, please.
Hello. My name is Qing Li. I'm a professor at Shijiazhuang Traditional Chinese Hospital. The paper I will be presenting today is estimate the infinite value of a circumference ratio. Let us begin. Don't open the share screen. One abstract effort to calculate the infinite value of the circumference ratio is made in this paper. Instead of being made of the countless infinitesimal,
Sir,
being
is this the presentation?
is part of a new defined infinity that is a single magnitude continuum derived from the changing direction that indicates that there is a damping from the finite
Prof.
to
Kingsley, I think
to
your screen is not showing now. We can see only your browser, your internet browser. You don't show us the presentation slides. Are you supposed to show us your slides? The one that you share now is your browsers, your internet browser.
the changing direction implied that infinite lengths can be defined as two parallel lines that never intersect. Which
Excuse me, sir.
denotes that only the
Sir?
terminal end of the first straight line.
Sir, we cannot see your presentation, sir.
Lee,
Excuse me, sir.
your slides are not visible to us. We are able to see only the browser which you have seen.
I request you to kindly please try again, sir.
Abstract one effort to calculate the infinite value of circumference ratio is made in this paper. Instead of being made of the countless infinitesimal, a billion circle is part of the new defined infinite. That's a single magnitude continuum derived from the changing direction that indicate that there's a jumping from finiteness to infinity. The changing direction implied that infinite lengths can be defined as two parallel lines that never intersect, which denotes that only the terminal end of the first straight line is meaningful when it is tending toward infinite distance, and this terminal end is defined as infinite length, which is magnitude that can denote this course, and magnitude outside of it. When the first straight line is turned to infinite distance, its one-dimension feature will be lost and become an infinite dimensional magnitude. The infinite value of the circumference ratio is this new defined infinite. To introduction, the circumference ratio pad is considered an infinite no cyclic decimal, and its approximate value is 2.1. So far, that is value to 105 trillion place of the decimal point have accurately means by the computer. However, no matter how this computer power of the computer can be improved, their computational accuracy of the pi can only stay at finite place and cannot reach the infinite place, since it is still bigger for our understanding the concept of infinitesimal and infinite. The partition measure is used to calculate pi in this paper. To calculate this infinite value of the pi of the decimal point, the circumference of the circle is divided into the 10 equal parts, 100 equal parts, 1000 equal parts, and so on. Correspondingly, the position of the diameter of this circle are between 3 and 4 parts. 3.1 and 3.2 parts, respectively. And so on. According to this partition trend, it can reasonably conclude that when the number of partitions reached infinite, pi value reached its infinite position value, which is infinite decimal place after the decimal point. However, this is paradox, because when this circle is partitioned by using the measure also called as the continuous partition, this partition will keep going ever, but cannot reach an infinite number of the partitioned value. So this continuous partition can only stay at a finite number of the partition value. It's not close to an infinite partition value, so it is unique, and there is no distinction between the maximum and the minimum value of this finite magnitude. This finite magnitude is a one-dimensional magnitude because assuming zero-dimensional 0 point is infinitesimal necessarily means that a maximum magnitude does not exist. 2. A new defined infinite. When this circumference can be infinitely partitioned, this partition is no longer continuous but a jump from finite division to infinite division, which is determined by the property of a new defined infinite that is magnitude that can never be achieved forever by forever extending continually finite magnitude. How to achieve this jump? I found that jumping from finite to infinite is implied by the changing direction. The changing in direction is the turning point of the direction change at an infinite distance site. That is unique. A jump from finite to infinite means that infinity is unique magnitude that no addition, subtraction, multiplication, and division operation can be performed on this infinite. So the new defined infinite is the accumulation of an infinite many finite magnitude by the changing direction. The changing direction implies that infinite length can be defined as two parallel lines that never intersect, which denotes that only the terminal end of the first straight line is meaningful when it is tending toward infinite distance. And this terminal end is defined as the infinite length. The first line is the infinite that you cannot talk about any magnitude outside of it. The second line does
Sir
not.
Lee, excuse me, sir. Excuse me, sir.
Uh,
We have completed the 9-minute mark. I request you to kindly conclude your presentation. And again, so we are unable to see your presentation.
oh, okay.
Okay.
Mm.
Professor Lee, might be you have shared a full screen to us. Your presentation is not with us.
Professor Lee, do we have you here still along with us? Um, Sir Lee? Okay. Said that there must be some problem with the systems because I have been asking him on the chat as well. However, he's not able to respond to us. So I would call upon our next presenter, sir, with your permission.
Sure, go ahead.
Yes. Thank you so much.
He's here.
Okay. Should I take up the next presenter?
Just wait for Lee if he's able to present that, then that's
Okay.
better.
Okay. Sir Lee, would you be able to present, sir?
Okay, then you can go ahead next week.
Yes. Okay, sir.
That will be better.
For our next presenter, I have Ahmed Alansari presenting a paper on the title Severity Aware Weighted Loss for Arabic Medical Text Generation. I request you, Sir Ahmed, to kindly start with your presentation, please.
Thank you for your introduction. Let me share my screen.
Yes.
Can you see my screen?
Yes, sir, we can see your screen.
Perfectly.
Okay. Good morning, everyone. I'm Ahmed Al Ansari from MSA University, and today I will present our work titled Severity Aware Weighted Loss for Arabic Medical Text Generation. The motivation behind this work comes from the rapid growth of Arabic telehealth platforms and medical question answering systems. Most existing language models treat all medical cases equally during training, regardless of whether the case is simple or clinically critical. However, in healthcare, not all cases have the same importance. A severe emergency case should have higher priority than a minor symptom inquiry. So our goal is to build a model that understands the difference and gives more attention to high-risk medical cases. The main objective of this work is to improve Arabic medical text generation quality and safety. To achieve this, we propose a new training loss function called Severity Aware Weighted Loss. This loss function prioritizes clinically critical cases during fine-tuning, helping the model generate more reliable responses in high-risk situations. In previous work, standard LLM training mainly relies on cross-entropy loss, which treats all training samples equally. This creates an important limitation because it ignores the clinical severity of each case. Recent studies also showed issues such as hallucination, overconfidence, and poor calibration in medical NLP systems. Despite these efforts, no effective approach has integrated clinical severity information directly into the loss function, which is the gap our work aims to solve. The problem is that current LLMs can generate fluent Arabic medical responses, but they lack clinical risk awareness. This means they may respond similarly to both low-risk and high-risk medical questions. Our proposed method introduces severity information into the training process. First, each medical question is assigned a severity labels. These labels can be hard labels representing the main severity class, which is like critical or neutral or non-critical, and soft labels representing probability distributions across multiple severity levels. Then we assigned different weights to each severity level, so the critical cases have much more weight. These weights are the balance. Yeah, we tried 3 settings in weights. The first one was giving more weights to not much more than the critical. We give the non-critical like 0.25 and neutral always 1, and the critical took 1.75. This made the the weights more about the critical, and another setting was 0.75 and 1 and 0 and 1.25. This also give less critical and more non-critical. The best setting is this 0.5 and 1 and 1.5. This achieved the highest results. We start with the standard cross entropy loss. Then we calculate the weighted severity score based on the probability of each severity class. And finally, the final loss is obtained by multiplying the severity weight with the cross entropy loss. This allows the model to penalize mistakes on critical cases more strongly than mistakes on low-risk cases. The research methodology consists of several steps. First, we classify medical questions according to severity levels. Then we calculate the probability distribution for each level. After that, we assign weights to the prioritized critical cases. And next, we fine-tune the LLM using our proposed severity aware loss. For evaluation, we used the Mecca dataset, which is an Arabic medical question answering system. This dataset is suitable for testing Arabic medical text generation models. However, one limitation is that it doesn't originally contain severity labels, which led to an additional challenge in our work. The main challenge is that it didn't provide severity labels, either hard or soft. To solve this problem, we fine-tuned Arabert as a severity classifier using a collected medical social media data. This classifier was then used to predict severity levels for Mecca sample. The classifier achieved an accuracy of 58%, which was sufficient for generating severity-aware supervision signals. The results demonstrate the effectiveness of our proposed loss function compared to the baseline model without fine-tuning, and model fine-tuned using cross entropy only. And this is mild settings, which is 0.5, 0.75, and 1 and 1.25. And this a strong one with 0.25 and 1 and 1.75. And this is a balanced one, achieved the highest results at all models. And this is the references. Thank you. Any questions?
Yeah, Ahmed, it was really great presentation, and the topic is also good. I'm just curious about to know, because your study is really based on that weight loss, right? It might be around the world people are suffering from the weight loss. Might be this study is really important for everybody to getting something. So can you give me the brief result about your study? Because you have taken that LLMs and the data analyticals you have taken. What's the brief
This is
conclusion? Yeah, okay, fine.
Okay, so you mean you want me to explain it again?
Yeah. No need to explain. What could be how your study could be beneficial to the society?
I'm sorry, I don't understand. Yani, what you mean?
I'm asking. You did some social aspects also in your study. Okay. So how your study will improve the social aspect?
What social aspect?
Social aspect, yeah, exactly.
Yeah, what is social aspect? I don't get it.
Basically, you're talking about the weight loss activities, right? With your
Yes.
research and result, how could you help others, people to do or adopt that? Means how they will adopt this model?
You mean as another domain, not
Yes,
just medical?
yes.
Well, it could be for. Honestly, I didn't think about that, but like it's my domain is the medical domain. But
Mm-hmm.
can you at least, يعني, can you give me an
Okay.
example the domain?
Yeah, I'm giving you an example. Your study is based on weight loss, right? You have
Yes.
taken a lot of data along with some LLM you have applied for. When we are
Okay.
connecting to the end result, so end user would be your patient or maybe anybody, any humans.
Okay. This
Okay.
it affects the generated responses,
Yeah.
which is treats. For example, a case came to the me as a patient talks to the LLM and say I have an headache. So the LLM treats it as a mild case. It just says, "Don't worry, it's something normal," and it calms
Okay.
the patient. Okay.
Okay.
On other hand, I could just say, "My heart, I have a pain in my heart," so it doesn't just calm the patient. No, it assists, give advice to visit a doctor.
Okay. Fine. Thank you so much for explaining. Yeah, Ayman,
Thank
if you have any question, you can ask.
Yes. Assalamualaikum Ahmed.
Alaikum salam.
Very interesting study. One of my research interests is also social media. When you say social media medical data, what
Yes.
what do you mean by that?
It was like a Facebook group contains that have members of patients and doctors, and patients post their medical cases, and specialized doctors respond for them, and we collect the data. That's for the classification of the Arabert only, not the training of not the weighted loss evaluation.
Oh, okay. So yeah, probably it is better for you to just mention it explicitly, textual data from Facebook, because when you say social medical data, it's going to be broad, right? Can be also visual, can be also video. So that's just an suggestion, Ahmad.
No,
Thank
it was
you.
only text. Thank you. Any other questions?
Thank you so much for your presentation, sir.
Thank you.
Thank you for our session, Jess. And now I would like to call upon our next presenter for the session. Our next presenter is Murtaza Ali, presenting a paper on the title Strategic Management Framework for Scaling Telemedicine in Rare Chronic Disease Care, a rapid review of rural India's digital health ecosystem. I request you to kindly take over with your presentation.
Thank you, ma'am. Am I audible?
Yes, sir, you're audible.
Perfectly audible.
Thank you, sir. So, shall I start?
Yes, please. Yes. Sir.
So, respected panel, why we have been sitting here for just 30 seconds? A child in a rural village, perhaps just a few hundred kilometers from the university I am being in, has started a 7-year wait. 7 years of misdiagnosis, 7 years of a diagnostic odyssey. In India, 100 million people suffering from rare diseases are invisible to our current healthcare system. Good morning, respected panel. I am Murtaza Ali, along with my co-author Ashita Shukla. We are here to present a strategic management framework for scaling telemedicine. Today, we aren't just discussing a health problem. We are presenting a scale blueprint to ensure that geography is no longer a destiny.
Okay, so to understand our solution, we must first look at why current models are failing. We have identified a triple crisis paralyzing a rural India. First, a triage failure. Rural patients simply don't know where to go. Second, a specialist chasm. We have fewer than 500 geneticists for 1.4 billion people. And third, the sustainability trap. Most telemedicine today is prioritized. It works as a small project but dies the moment funding stops. Our research didn't just look at the surface. Using a constructive approach and the CFIR framework, we conducted a systematic review of over a decade of data. We synthesized 41 critical systemic gaps across three levels: macro, meso, and micro. We didn't just find that the technology was missing, we found that strategy was missing.
So, as management students, this is where we found the master gap. Telemedicine is often treated as a technical utility, like a video call. But through the lens of Michael Porter and Henry Mintzberg, we realized it's a failure of organizational configuration. We are missing a strategic architecture to bridge the gap between urban expertise and rural reality. This vacuum is what prevents a pilot from becoming a system. So, this brings us to our most significant contribution, the frugal value change. Uh, just a second, Contribution to the frugal value change. We are proposing a strategic decoupling of healthcare.
Exactly. In our model, the urban hub acts as the digital brain, handling high-end genomics and specialized diagnosis. Meanwhile, the rural spoke act as the physical hand. By using local health workers as digital proxies, we ensure the data moves even when the patient cannot. To operationalize this, we develop scale blueprints. S is for strategic integration with national mission. C is for clinical competency training local workers. A is for accessible triage using offline first AI. L is for long-term financing shifting from donations to value-based care. E is for evidence-based metrics. The result of the blueprint is STRC model. It functions in three layers: the shield macro policy, the engine meso level institutional scaling, and the contract micro level patient trust. It is a modular system, meaning we can plug in new rural spokes into an existing urban hub without starting from scratch.
Okay, so moving ahead, now let's talk about the bottom line. Okay, so efficiency. Every year of misdiagnosis is a sunk cost. By applying value-based healthcare principles, the STRC model reduces diagnostic waste up to 40%. We are shifting from a high-cost capex model to a lean, scalable opex model. This isn't just a social service; it's an optimization of healthcare economy. Uh, so moving ahead, the logic of this model is universal. Whether in Vidarbha, a particular region of India, or any other low resource setting in the global south, the bottlenecks are identical. Our framework is born in the global south for the global south. Okay, so it proves that innovation isn't just about making things cheaper; it's about making strategy smarter.
Okay, so in conclusion, we have moved from identifying 41 gaps to providing a validate roadmap. Our goal is to reduce diagnostic odyssey from 7 years to 7 months.
So, respected panel, we believe this research demonstrates how management theory can solve real world crises. We are ready to take this framework to the international stage and prove that unique strategy creates life saving value. We thank you for your time and welcome your questions.
Thank you so much for presenting your paper. It was really a nice presentation. Can you go on second slide, please?
Sure, sir.
Yeah.
Yes, sir.
So this you have mentioned about the crisis in India, right?
Yes, sir.
And go to the next slide. Next
This is
slide.
his methodology that we have used, sir.
Yeah. So can you explain again, please?
See, very practically speaking, sir, our paper was a review paper based on secondary research. So the methodology which we used to move ahead was like we have searched a diverse portfolio, including our topic related data, and our research philosophy was really simple. Our research philosophy was like we need to deep dive into the three levels in which we have bifurcated the regions: the macro level, the middle level, and the micro level.
Yeah.
And
So
accordingly, we have detected the gaps, the 41 gaps, what we mentioned in our presentation.
agree with you, but what are the bases? You have taken this about for the gaps. So when you worked on the literature, okay, have you categorized the literature as well?
Sure, sir. Uh, like if I have the permission to present my uh, paper,
No, it's okay
so
because we do not have time. Just I want to discuss about that the category of research you did. So have you categorized your literature as well in this study?
not in the presentation, but yes, in our research paper which we have prepared and submitted.
Okay, fine. Thank you so much. Done from my side. Everyone,
Thank
if you have any question, you can ask.
Oh, okay. A good study, literature review article is also a good one. So my question is, what database, what literature database that you go for your search process?
Okay. So thank you for the question, sir. So exactly the similar kind of question which Dr. Sir asked us previously. So so sir, the base which we have taken to move ahead for our study was like, see, here we have mentioned constructivist epistemology. So what does this mean is we have taken the data and bifurcated into two types. Firstly, all the secondary data which was formally mentioned into the governmental websites and all. So we have extracted the data out from here. And secondly, we have interviewed certain rural areas on our behalf. And by mixing these both of the things, we have made and constructed a base on which we have worked ahead.
Is there any academic database that you go to?
Sir, I'm really sorry to say, but we have not mentioned the exact table into our presentation due to time constraints. But yes, the research
Sure.
paper which we have submitted earlier, we have on the last page of research paper, we have made a tabular format and mentioned
Sure.
specific case studies or specific research which we have reviewed and the gaps which we have taken for our study.
Okay, thank you so much.
Thank you, sir.
Thank you so much for your presentation. Now I would like to call upon our next presenter. Our next presenter for this session is Ong Nyung Chan Peng, presenting a paper on the title Olma-based retrieval augmented generation for PCOS diagnosis support system, a locally deployed conversational AI approach. I request you to kindly take over with your presentation, please. Sir Peng.
Yes, ma'am.
Yes, sir.
Good afternoon, everyone. My name is Ong Nyung Chan, and I would like to share my paper presentation.
Yes.
So today I would like to present my work on a local deployed privacy preserving AI system for PCOS diagnosis support, built using RAG workflow with Ulama. Here's a quick roadmap. I will walk you through the problem, our system design methodology and results, and close with limitation and future directions. PCOS affects 6 to 12% of women of reproductive age, yet the average time to diagnosis is nearly 7 years. The comorbidities are serious like type 2 diabetes. Type 2 diabetes risks can triple. And despite the rise of AI tools like ChatGPT, two major gaps contain. First, they lack PCOS-specific clinical accuracy. And second, cloud-based system raise serious patient privacy concerns. And my work directly address both. As the prior work, and CNN-based imaging model achieving over 95% accuracy on ultrasound images data, and LLMs like ChatGPT for general women health query. However, ChatGPT still hallucinates and remain a concern, and RAG system cover it while wanting to reduce the hallucination and not to be apply PCOS in local, and it make the privacy safe deployment, and that's our gap. Our pipeline has 4 components. Every user query first hit a relevant score, and I will explain this in detail shortly. Like relevant queries, then 12 document PCOS 12 documented PCOS knowledge base, and most of the sources are taken by reliable sources like Mayo Clinic, NHS, ACOG, and WebMD. These are injected as context into LMR 3.2 and running fully locally via Ulama on localhost. The system maintains a 6-turn conversation memory, and it always add a clinical disclaimer at the end. The most novel part of my system is there are 3-layer relevance score. Layer 1 instantly pass any query containing PCOS as a keyword or direct synonym with 0 fault and a negative there. And layer 2 handle symptoms based query like irregular periods using keyword expansion plus semantic similarity. If it is related to hormonal balance and this kind of related words, it will let it pass. In layer 3, it evaluates ambiguous queries against a cosine similarity threshold of 0.65. Queries below that are gracefully deflected. This architecture was validated on 20 query tests that converting and is covering direct PCOS, indirect health, and related queries. As the experiment setup, the system is implemented in Python 3.1 with modular code base, Jupyter.py, RAG engine of Py as a main working file, and then one knowledge module. It runs entirely offline with no cloud calls, making it GDPR aligned and suitable for clinical environment. For the result and discussions, our works are strong, and the results are also firm. We achieve 100% accuracy on direct PCOS queries, a top relevance score of 0.89 on diet and nutrition queries. Response latency latency of 2 to 8 seconds because not like other model, it generates the whole paragraph, so it take a little bit of time. And 100% disclaimer compliance. The relevance classification table shows the guard correctly, patient symptoms, queries, and deflecting and related ones like how to cook chicken. It will respond to that one. And argument responses will noticeably more specific than a vanilla LLM baseline. Limitation and future work. Our knowledge base have still need manual KB update. We need to do it. We need to do the update manually because it cannot be automatic. It cannot be automatically bring the data from the outside. And also the keyword coverage with no also we also doesn't have have test at a real clinic and using the smaller LLM than ChatGPT, so than ChatGPT-4. So complex multi-faced clinical query may lack insurance. For the future work, I would like to automate KB science and then do the actual clinical test validation and operate with larger LLM open sources. As the conclusion, I would like to summarize the presentation. The first locally deployed privacy-preserving PCOS RAG system with a novel 3-layer relevance curve and evidence-based 12 domain knowledge base and consistently high relative quality. We believe domain-specific private AI is the future of accessible women's health support. Thank you. References are on the next slide, and I'm happy to take questions.
Yeah, it's really very good presentation, and the theme is also very relevant as per the present requirement. I don't have any question from you, right? Well done. It's really good study.
No question from me. Congratulations on this study. It's well written and well managed. Thank you.
Thank you so much for your presentation, sir. Mr. Peng, thank you for your presentation, sir. I would like to call upon our next presenter. Our next presenter is P. Abhivarshini, presenting a paper on the title, Claim Watcher, a smart healthcare insurance fraud prevention using privacy-preserving, decentralized intelligent framework. I request you to kindly take over with your presentation, please. Ms. Abhivarshini. Ma'am, I request you to kindly take over with your presentation, please.
She's here, but she's not responding.
Not responding to us. Meanwhile, I'll just call up our next presenters that we have right now. They are not in the meeting, sir. However, I have to call out their names. If anybody is on behalf of them, I request you to kindly take over. So Deepak Sharma presenting a paper on bibliometric analysis of research trends in finance, mapping intellectual structure and emerging themes. Anybody on behalf of Sir? could please take over if they are available over here. Okay. Next we have Isha Bhagat presenting a paper on the title A Review of Worker Safety Assurance and Automated Industrial Quality Inspection and the Proposed AI-Powered System. If we have anybody on her behalf, anybody presenting this paper, I request you to kindly join in. Ms. Abhivarshini, ma'am, would you like to take over with your presentation? Do we have any network issues? If you can not present your PPT, you can just send it to us. Ms. Abhivarshini?
She's available in the chat.
Yes, sir, she is.
Yeah.
Okay, yes. Ma'am, is there any problem with your network?
Yes.
Ma'am, you're audible, however, because of that network error, you're basically cracking, the voice is cracking of yours.
Ma'am, a minute, Ma'am, am I audible now?
Yeah,
Yes,
perfectly
now
audible.
you're audible. Yes.
Yeah, thank you. Let me share my screen. 1 second. So give me a minute, I'll share my screen. Yeah, I'm sharing my screen. 1 minute. Hello, ma'am, is my screen visible?
No, ma'am, not yet.
Oh, just a
Yeah,
second.
now visible.
Yes. So yes, sorry for the network issue. So firstly, good afternoon, everyone. This is Abhivarshini. And today we are honored to present our research titled Claim Watcher, that is a smart healthcare insurance fraud prevention using privacy preserving decentralized intelligent framework. So our research addresses one of the most persistent and costly challenges in the healthcare sector, that is insurance fraud. So let me go to the slideshow firstly. So yeah, is my screen visible, right?
Yes, ma'am,
Hello?
it is visible.
Yes,
Yes,
ma'am.
ma'am.
Yeah, thank you. So basically, traditional insurance operations are currently plagued by fragmented data sharing, slow manual validation, and weak identity verification. So these inefficiencies lead to massive financial losses and also lack of trust. So our claim.
Actually, you're not audible to us.
Ma'am, there's some network issue now again. We cannot hear you.
Oh, okay. Give me a minute. I'll try to
Now
switch.
it is fine. Now it is fine.
It is fine.
Yes, right now I can hear you clearly.
Yeah, thank you. So basically, traditional insurance operations are currently plagued by fragmented data sharing, slow manual validation, and weak identity verification. So these inefficiencies lead to massive financial losses and also a lack of trust. So Claim Watcher is our solution. That is a decentralized framework that uniquely integrates blockchain, self-sovereign identity, AI, and federated learning. So our system delivers a secure identity management and intelligent claim verification. Most importantly, it allows for collaborative learning between institutions without compromising raw patient data. As we can see later that our evaluations show a 94% fraud detection accuracy and a significant reduction in processing time from days to just minutes. So why is it necessary is because insurance fraud ranging from identity theft to manipulated documents, it costs billions annually. So current gaps include a centralized databases that serve as single points of failure and data silos that prevent AI from being truly effective. The innovation of Claim Watcher lies in its unification. While many systems uses blockchain or AI, no prior framework has successfully unified all the four pillars. So blockchain, AI, SSI, and federated learning into a single functional insurance ecosystem. So we use Ganache and MetaMask for our blockchain layer and a Gemini-based medical reasoning engine for our AI. In order to address these issues, we have set our 5 key objectives to establish a decentralized identity where policyholders control their own decentralized identities, to ensure all the records are on-chain for tamper-proof auditability, and to deploy a medical reasoning engine to generate automated credibility scores, and to also use federated learning to aggregate encrypted model weights rather than raw data. And finally, to build a functional prototype using web technologies. So we have searched for several recent works, and they have successfully proved that combining blockchain with self-sovereign identity can significantly reduce the identity fraud and also automate policy issuance. However, the major research gap here is the lack of intelligent verification. So these systems can confirm who a person is, but they cannot intelligently analyze what is being claimed.
Ma'am.
Of privacy preserving collaboration. Their model often rely on centralized data, which creates a single point of failure and raises significant patient privacy concerns. And like furthermore, they do not incorporate decentralized identity management, leaving the system vulnerable at the user entry level. Most recent works explored federated learning to train the models without sharing raw data. While this addresses privacy, there also remains a functional gap in stakeholder diversity. So these frameworks often miss the decentralized identity component for the policyholder or the automated reasoning engine for the real-time claim analysis. So Claim Voucher fills these gaps by being the first unified framework to integrate all four: blockchain for auditability, SSI for identity, AI for automated fraud scoring, and federated learning for privacy preserving growth. Now let's have a look towards our methodology, that is system architecture. So which is our backbone of the claim voucher framework. Our architecture is basically designed using a multi-layered approach in order to ensure modularity and security. Firstly, we have user layer. We have three primary stakeholders. The patient interacts via an SSI linked profile in order to manage their digital identity. The hospital acts as the data provider, uploading diagnosis reports and billing details, while the insurance company utilizes the dashboard to review AI generated scores and settle claims. Then we have the blockchain layer. So this is the source of truth. We utilize Solidity smart contracts on an Ethereum testnet in order to handle the policy logic and claim records. In order to avoid this bloating, the blockchain with heavy or medical images or PDFs, we use IPFS for off-chain storage, recording only the immutable cryptographic hashes on-chain. So coming to the intelligence layer, this is where Claim Voucher differentiates itself. It consists of two submodules, that is AI verification, a medical reasoning engine powered by the Gemini API, and analyzes the claim details against medical logic to detect anomalies like phantom billing or treatment mismatches. Then comes with federated learning. Instead of a central database, each institution trains its own or local model. We then aggregate only the encrypted model weights, ensuring that the sensitive patient data is never going to leave the hospital's local environment. In order to understand how these layers are actually going to interact, let's walk through the end-to-end workflow of the claim. So firstly, we are going to identify, it begins with a patient creating a self-sovereign identity. A unique decentralized identifier is generated and it's anchored to the blockchain. When a policy is issued, it is cryptographically linked to its DID, making the identity theft nearly impossible from the start. So when a
Miss Varshini.
Network issue, I think.
Okay, sir. Ma'am, can you hear me?
We can go on next.
Sure, sir. I'll just have one more paper title over here with me. I'll just present it. If that person, we don't have the author over here, however, we'll just call out if anybody else is presenting on his paper. We have our author, Deepak Sharma, presenting a paper on the title GST Frameworks Across Borders, a Comparative Study of India and Global Models. Sir, if anybody is present on his behalf, I request you to kindly take over with the presentation, please. Anybody on behalf of Sir Deepak Sharma?
Nobody's there.
Okay. Ms. Varshini is also not available, sir. With this, actually, we come to the end of our session. So I would like for you to kindly conclude, sir, if any thoughts or any words of wisdom that you would like to give to our
Thank you so much.
presenters.
Yeah, thank you so much, Prachi. It was really good insight given by all the paper presenters. Some topics are really very relevant and are very positive for future development and future research also. Especially, I'm very happy that some presentations relating to medical sector and data-driven LLM was also being involved, which was really remarkable in this session. And I would say that, of course, there's a need of development. Some papers are very below to the mark, and we need to focus on some implementation of technological advancements while presenting the paper, because some additional social relevance is required. Whatever we are presenting in our paper or whatever we have analyzed through data, that requires some social importance, that ultimately how it will be used for the society. That is my message to all the researchers and paper presenters. Thank you so much for giving me the opportunity to interacting to all of you. Thank you. Yeah.
Dr. Rayadi, sir, do we have any feedbacks or any sort of suggestions from your end for our presenters today?
Having with Dr. R.K. Taylor. I really appreciate this opportunity. I mean, all of this presentation and the study, how technology and this era, I mean, this type of knowledge has been circulated and then distributed in different countries, and we've seen from different universities and different countries. Thank you very much for the opportunity. Thank you.
Thank you so much, sir. Now, just like to I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this 11th version of our session and all the previous 10 versions of this conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publications will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Now, I would like to show our token of appreciation from our end for our session chairs. We thank you, Professor R.K. Taylor, for chairing our session, sir. And we thank you, Professor Rayadi, for chairing our session, sir. Thank you so much. Now, I just request all of you all to kindly switch on to your camera so that we can have a quick snapshot of this virtual session we just attended. Requesting all of the participants, the presenters, to kindly switch on to your cameras for a quick snapshot. Kindly please switch on to your cameras quickly. Thank you so much. Now you may exit. Have a safe time ahead. Thank you so much. Thank you for being here. Thank you.
Link in, okay?